In this lesson, we are going to go over logarithmic equations. Specifically, here we'll understand logarithmic equations, and we'll solve logarithmic equations by converting them to an exponential equation. So first, logarithmic equations are equations with variables in the logarithmic expressions, so inside of the logarithm. So in order to solve logarithmic equations, make each side a single log if possible, then convert it to an exponential equation, solve, and then make sure you check your solutions. And so there's a couple key things to remember here. Remember that we said y is equal to log base a of x. So a has to be greater than 0 and not equal to 1, and x has to be greater than 0, which is why it's important for us to check our solutions. Also remember that we can convert this to an exponential by doing a to the power of y equals x. So example 1, solve for x. So we have 3 times ln of x is equal to 21. We have a single logarithm on each side, but we have 3 being multiplied by ln of x. So what we can do is we can divide by 3 on both sides. So multiplication by 3 and division by 3 cancels, and we're left with ln of x is equal to 21 over 3 is 7. So now we can convert it to an exponential equation. Remember, ln is log base e. So this is e to the 7th is equal to x. Okay, so we've solved for x. Now we can check our answer, and so to check it, we plug in e to the 7th in for x in the original equation, and we want to know if that's equal to 21. So using properties of logs, the 7 can come down in front as multiplication. So this is 7 times 3, ln of e, and we want to know if that's equal to 21. 3 times 7 is 21. ln of e, this has the base and the expression are the same, is just 1 is equal to 21, so it checks out. Our answer is e to the power of 7. Next, solve for x. So we have log base 5 of 4x minus 2 is equal to 2. Okay, so we have a single logarithm, so we can convert this to an exponential equation. So 5 to the power of 2 is equal to 4x minus 2. So 5 squared is 25. This is equal to 4x minus 2, and we solve this like we would any other linear equation. So we add 2 to both sides, and we have 27 is equal to 4x. To solve for x, we divide both sides by 4 to get x is equal to 27 over 4. Now we can check our answer again by plugging it back into the original equation. Minus 2 is equal to 2. Okay, so inside we have 4 times 27 over 4. The 4's cancel, so we have log 5 of 27 minus 2, and we want to know if that's equal to 2. 27 minus 2 is 25, and 5 squared is 25, so this checks out. Next, solve for x. We have log base 4 of x cubed plus 37 is equal to 3. We have a single logarithm. The other side is just 3, so we can convert this to an exponential equation by taking 4 to the 3rd is equal to x cubed plus 37. 4 to the 3rd is 4 times 4 times 4, which is 64. So we have 64 is equal to x cubed plus 37. Okay, and so now we can solve this for x. So we subtract 37 from both sides to get 27 is equal to x cubed, and we can take the cube root of both sides. So when we take the cube root, we're looking for what number times itself 3 times is equal to 27, and the answer is 3. So we get x is equal to 3, and you can plug it in and check. The main thing, if we substitute 3 in, 3 cubed is 27 plus 37 is going to end up being positive. Example 4, solve for x. So we have log base 2, and then inside of the logarithm, we have x plus 4 times x minus 3, and this is equal to 3. So let's convert it to an exponential equation. So we have 2 to the 3rd is equal to x plus 4 times x minus 3. So now we need to expand both sides. So 2 to the 3rd is 8, and we use FOIL on the right-hand side. So x times x is x squared, x times negative 3 is negative 3x, 4 times x is 4x, and 4 times negative 3 is negative 12. So this gives us 8 is equal to x squared plus x minus 12. So we have an x squared, so this is a quadratic equation. where our goal is to get everything to one side and set it equal to 0 and try to factor and solve. So we subtract 8 from both sides, and we have x squared plus x minus 20 equals 0. So we look for two numbers that multiply to 20 and add to x. So we have x plus 5, x minus 4 equals 0, which will give us x is negative 5 and x is 4. Okay, now we do need to plug both of these in to make sure that we don't get a negative inside of the logarithm. Remember, all of this has to be greater than 0. Okay, so we'll check. So first we'll do x is negative 5. So we have log base 2 of negative 5 plus 4 times negative 5 minus 3. Is that equal to 3? So if we keep going, negative 5 plus 4 is negative 1. Negative 5 minus 3 is negative 15. So this is 15 is equal to 3. Sorry, negative 5 minus 3 is negative 8, not negative 15. I was multiplying those. So then we have 8. And 2 to the third is equal to 8. So that one checks out. Okay, we can also check x is equal to 4. So we have log base 2. If I plug in 4, 4 plus 4 is 8, times 4 minus 3 is 1 is equal to 3. And we have the same thing, where 2 to the third is equal to 8. So we do have two answers of negative 5 and 4. I think that's it. Thank you for watching. If you have any questions, feel free to reach out to me.